Okay. See, now this is working. Now this is working like the way I want it to be working. All right, that's great. Now, is there any desktop audio? Doesn't seem to be, but that's fine. I probably could have done that without stopping stream too. I just didn't realize I wasn't clicking on it because OBS is not does not get along with my drawing pad. So what I need is I need to show that the spanning list is equal to the dimension of the ambient space. And if I can show that, then I can then I'll be fine. Suppose that is, but I don't know if I have that lemma. So the lemma I want is span S equals V, then dim S equals the cardinal. No, I'm sorry, dim V. Where's my eraser? Then dim V equals cardinality of S. That's what I want. If I have that, then I'm in business. If I have that, then I'm in business. So I need to find that in the text. If it's not in the book, then I won't be able to use it. The span of a list of vectors is the smallest subspace of V containing all. That doesn't help. Unless I could derive what I want from that, but that would be awesome if I could derive from this. Streaming.
How come I don't hear anyone?
I'm streaming. Ask them to explain what a stream is. If I Oh, you know what? You know what I wanted to do? I wanted to pull my stream manager into my other monitor. There we go. So now I have my stream manager and my other monitor. That's much better. And you can exit it out there. It's much better. So, like I was saying, this is the lemma I want. And I don't know how I'm going to get it. I feel like it's a remark. I remember seeing this as a remark. I remember seeing it as a remark. The additive identity is in span. No, so that's easy. That's just a subspace. That's show that it forms a subspace. If some list of vectors spans the space. So yeah, every list has finite length, and I'm given a finite list and saying that it spans. I'm given a finite list and saying that it spans V. So I know that V is a finite dimensional vector space. Now, do I know that its dimension is exactly equal to the cardinality of the list? With the usual operations of addition and scalar multiplication, P of F, which you should verify. I know that. I don't need to verify it. I mean, I should. Then it goes to linear independence. This lemma isn't here. This lemma isn't here. So how am I going to show for arbitrary vector space? I made progress on this last week. Let X in V. So let's prove it assuming we have this lemma and then worry about whether or not we have the lemma later. Is that what I want to do? My foot's asleep. I was sitting on my foot like an idiot. Because here's the thing. So if I have this, then I know that x equals x1, x2, x3, x4. Then I know that x1 v1 plus x2 v2 plus x3 v3 plus x4 v4 you know what? I'm just going to say sigma xk vk k equals 1 to 4 xk in field of V. Lee, Lee, Lee. Lee, Lee. Equals V. I'm pretty excited about the code I wrote. Not working on it today, but xk. So what that's doing is that's just restating this, right? That's just span of v1 through v4. So what I want to do is I want to do this. So I'm ready to get started now. I've done enough messing around. This is going to be equals yeah, I don't know if I like this very much, but x1 times 1 times v1 plus x2 plus 1 minus 1 times v2 plus x3 plus 1 minus 1 times v3 plus x4 plus 1 minus 1. This is what I did last week. Times v4. Then we get, let me just write x1 v1 plus x2 v2 plus v2 minus v2 plus x3 v3 plus v3 minus v3 plus x4 v4 plus v4 minus v4. And then we're going to have, now it's grouping, right? Now we put x1 v1 minus v2. But what we need is minus x1 v2, right? So what we need to do is we need this to be x1 and x1 in front of the minus sign. So I'm going to erase and rewrite it because I screwed it up. Wait a minute. This is going to be bad business. What we need is we need to distribute out. And we don't have guarantees. We don't have guarantees that like xk is not equal to 0. What's up, viewer? How's it going? I like looking at the stream. You know what I mean? X1 V1 minus V2. The problem is there's going to be leftovers. And you need to think about what those leftovers are going to look like in advance. X1 V1 minus X1 V2 plus X2 plus X1 V2. And this, instead of 1 plus 1, we do x2 plus x1 minus x2 minus x1. So that's going to be minus x2 plus x1 v3. So that equals x1 v1 minus v2 plus x2 plus x1 v2 minus v3. And instead of this 1 plus 1, it's sigma k equals 1 to 3 of xk minus sigma xk k equals 1 to 3. So this is going to be plus this is going to be plus x3 plus x2 plus x1 v3. Minus x3 plus x2 plus x1 v4. Plus sigma xk k equals 1 to 4 v4. So that equals plus sigma k equals 1 to 3 xk v3 minus v4 didn't even start at the top. Plus sigma k equals 1 to 4 xk v4. Or v is of the form f to the s. So basically, since these are all real numbers, Then we're going to go like this. Let's draw in, do I have dark green? I don't have dark colors. Let's P1 equal X1, P2 equal X1 plus X2, P3 equal X1 plus X2 plus X3, P4 equal X1 plus X2 plus X3 plus X4. So what that is that's in the set of P1 V1 minus V2 plus P2 V2 minus V3 plus P3 V2 V3 minus V4 plus P5 V4 such that, darn it, such that P1, P2, P3, P4 are in F. Are in F. Now this is dependent on this. On the fact that because the span of S equals V, that the dim of V equals the cardinality of S. Which is another way of saying if the span of S is V, then V is of the form F to the cardinality of S. For some... Oh, I'm going to close the door real quick. And we're done. Right? Because the next thing you do is you basically say, since X was arbitrary, then for all X in V, X is in P1, V1. No, what was it? P1, V1 minus V2 plus P2, V2 minus V3 plus P4, V3, V3 minus V4 plus P4, V4 such that PK is in F. I want to go to Twitter. And type this in. I need to log in. okay, I don't do a lot of my passwords in the browser, but I do some of my passwords in the browser. Um, okay. What was I doing? What I want to do is I want to ask Twitter. Hey Twitter, if S spans V can no. I did not open the developer tools here. I am not a web developer. Okay. If SV, can I conclude that dim V equals card of S? In other words, is S spans V sufficient? Maybe polynomials is a counterexample to this. Maybe polynomials is a and let me. Hey linear algebra Twitter. Is S spans V sufficient? Hey linear algebra, who should I tag? Let's tag Daniel Litt because and Tyden A. Bradley. Let's just do those two. Because Tyden A. Bradley has posted some really good linear algebra posts. Am I saying that right? Yeah. Tweet. Let's see how this goes. All right, so let's so basically if it's of the form f, then I can clearly deconstruct it this way as such. All right, let's move on. Let's just delete, because with my last Paint app I couldn't even save, and with this Paint app I just won't save. Talk about. Oh yeah, okay, here we go. What am I talking about? Going back to the exercises, verify the assertions in example 2.18. I think I did this already. I want to find a number t such that 314, 2 minus 35, and 59t is not linearly independent. want to find t such that dep 2 minus 3, 5, 5, 9t. Such that dependent 314 2 minus 3 5 t. So let me actually go to Wikipedia because that'll be faster. See, I already have a notification. No, that was just to log in on the new device. All right. Let's see if any replies pour in. Linear independence. Wikipedia. The reason I'm going to Wikipedia is because if I recall correctly, Wikipedia has a list of properties that are equivalent. And I don't actually remember what they are. There's a list of properties that are equivalent to linear independence. Linearly dependent. All right, so let's just the augmented matrix is 3 1 4 2 minus 3 5 and 5 9 t pipe 0 0 0. Am I really going to row reduce this bad boy? I guess I am. What is this, amateur hour? Row reduction? Row 2 replaced with 3r2 minus r1. Row 3 replaced with 3r3 minus 4r1. 3 2 5 pipe 0. 3r2 minus r1 is 3 minus 3 is 0. Is minus 9. Minus 2 is minus 11. Is 27 minus 5 is 22. And this is going to be 3r3, that's 12, minus 4r4, that's 4r1, that's 0, because that's 12 minus 12. This is going to be 15 minus 8. What's 15 minus 8? It's 7. And this is going to be 3t minus 20. And this is going to be 0, and it's going to be 0. All right, let's do R1 replaced with minus 11 R1 minus 2 R2, I believe. And R3 replaced with minus 11 R3 minus 7 R2. Now, I might have screwed up with the minus signs. Minus 11R1 is minus 33. This is minus 22, minus 22. So this is actually a plus. So this is going to be minus 33 plus 2R2. That's minus 33, which is what I had. This is going to be minus 22 plus minus 22. No, that is a minus sign. Minus 22. That's going to be a 0. And this is going to be minus 55 minus 44. That's minus 99. It's going to be 0 minus 11, 22. There's going to be a pipe 0, 0, 0. And R3 is going to be minus 11, 0 minus 2R2, that's 0. This is going to be minus 77 minus minus 77. That's going to be 0. And this is going to be minus 33T plus 220 minus 7 times 22. Minus 154. And 220 minus 154 is 66. Yeah, so it's, yeah. Now we're going to go about row 3. So we're going to do R1 is replaced with, well, first of all, let's actually do a division step now. Let's do a division step now. This is going to be 1, 0, 3. This is going to be 0, 1, minus 2. And this is going to be 0, 0, T minus 2. Pipe 0, 0, 0. Now I can much easier do R1 replaced with T minus 2 R1 minus 3 R3. And R2 is going to be replaced with T minus 2 R2 plus 2 R3. T minus 2, 0, 0. 0, T minus 2. 0. Pipe 0, 0, 0. And this is going to be 0, 0, T minus 2. And essentially we're done. So as long as 2 is not equal to 2, in fact, we're just going to do this. We're going to do RK is replaced with 1 over T minus 2 RK. That's 1 0 0 0 1 0 0 0 1 pipe 0 0 0. I don't know about that. That sip of coffee, don't know about it. All right, so the answer to this problem is not linearly independent. So is dependent, right? So the answer to this problem is t equals 2. We want t to equal 2, and that will make this to be linearly dependent. Good job. Verify the assertion in the... All right, I'm just going to call it on this. I'm going to say if... No, I'm not going to call. I'm going to do a check. If t equals... There was a coffee grind in that last... There was a coffee grind in that last sip of coffee, so... Excuse me. Bum 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 bum. If t equals 2, then dep of 314, 2 minus 3, 5, 5, 9, t. Do I have room for a check? Do I have room for a check on this page? So we need to go back before... No, it's still independence. If some vector in a list of vectors V is... Yes, that makes sense. Let's try to solve this. A1, 314 plus, let's just do A plus B plus C, plus B, 2 minus 3, 5, plus C, 5, 9, 2, equals 0, 0, 0. 3a plus 2b plus 5c equals 0. A plus minus 3b plus 9c equals 0. 4a plus 5b plus 2c equals 0. So that's going to be 3, 2, 5, 1, minus 3, 9, 4, 5, 2. A, B, C equals 0, 0, 0. I don't want to row reduce this again. I just row reduced this. But now if I row reduce it, I'm going to zero out that row. So this row, at this step, this row is going to get zeroed out. Dot, dot, dot. And it's going to be A equals minus C, 3C, and B equals 2C. And C is like a free parameter. Because that's going to be Hermite form. If T equals 2, then this is Hermite form. Now, what does that mean? Does that mean dependence? Yes, it does mean dependence because P replaced with 1. A, B, C equal minus 3, 2, 1. Which means that the solution to A V1 plus B V2 plus C V3 equals 0 is not uniquely A equals B equals C equals 0. Which means dependence. Which means dependence. So we are done. That was a check. I'm really glad we did that check. That would have been really bad if we didn't do that check. The second bullet point in 2.20. 77% is optimal. It's much better than 66. Okay. And better than 100. 2, 3, 1. 1 minus 2, 1 minus 1, 2, 7, 3. C is linearly dependent if and only if C equals 8, as you should verify. It's going to be the same thing as last time. It's just going to be very boring row reduction. Do I feel like doing row reduction? I get enough practice row reduction, right? Like I tutor basic linear algebra already, so I get enough practice doing row reduction. I don't think I want to do it. I think I want to skip this one. And maybe I'll write it down in my debt document. So... So we skipped 4. So this is going to be good. So if we think of C as a vector space over R, then the list basically 1, 1, 1 minus 1 is linearly independent. So yeah, like we're talking about end 1, 1, 1 minus 1. Okay? Because basically what C is, like 1 plus I is defined as the vector 1, 1. And 1 minus I is defined as the vector 1 minus 1. Let's check out on Twitter to see if anybody responded. Oh, look, 2 likes and 2 replies. Nope, a spanning set could generally be much larger than a basis. In particular, oh no. A spanning set could generally be much larger than a basis. In particular, take any basis, then add any... Here, I need to make it bigger. Am I writing big enough? Is everything big enough on the screen? Everything's big enough. It's fine. Who liked it? Alright, thank you. I'm going to like, and I'm going to like to say thank you. Nope, a spanning set could generally be much larger than a basis. In particular, take any basis, then add anything to it, and you'll still have a spanning set. Generally, it's the size of a basis that we mean by dimension. Nope, for example, you could take S to be all of V, which would have an uncountable cardinality of V is a complex vector space, even if V is finite dimensional. which would have uncountable. Okay. That answers that, everybody. Good thing we did Twitter in the middle of the stream, huh? All right. Now, does that mess up my first exercise? I feel like it does. Except what I feel like, and this is something I was saying to myself. I wasn't saying out loud, so excuse me. But I feel like Axler doesn't want us to think of that. I feel like based on the context of the way he's been doing this chapter, is he wants us to infer that we can decompose it into f to the n, f to the 4. So the basis of C is defined to be. I mean, the standard basis on C is defined to be 1i. I am familiar with this basic philosophy that C is a vector space over R. Linearly independent. So yeah, I just gotta show that this is linearly independent. So I just gotta show that A1, 1 plus B1 minus 1 equals 0 implies A equals B equals 0. So that's going to be 1, 1, 1 minus 1 pipe 0, 0 is equivalent to R2 replaced with R2 minus R1 minus 1 is minus 2. And this is going to be R1 replaced with minus 2 R1 minus R1 minus R2. Minus 2 minus 2 minus minus 2 is 0. And we're done. We did it. Right? That's as simple as that. I don't need to do any other checks. Now show that if we think of C as a vector space over C, then the list 1 plus I, 1 minus I is linearly dependent. So this I don't understand. This is much more difficult. Think of C as a vector space over C. How do you think of C as a vector space over C? One plus I and 1 minus I would be basis vectors. No, they wouldn't be basis vectors because as a set of vectors, they're linearly dependent. So they would not form a basis. C is a vector space over C. Oh, no. This is easy. This is totally easy. Because all we're doing is we're showing that Z 1 plus I plus Z2, Z1 1 plus I plus Z2 1 minus I equals 0 implies that Z1 equals 0 plus 0I equals Z2. Right? So what that means is let A plus IB equals Z1 and C plus ID equals Z2. So we get A plus IB 1 plus I plus C plus ID 1 minus I equals 0. And what that's going to show is that's going to show that this is not uniquely 0. It's going to show that this is not uniquely 0. So let's begin. Let's do. Let's just recall that A plus IB times C plus ID equals AC minus BD plus BC plus ADI. Right? So that's going to be A minus B plus BC minus AD. That's plus AD plus A minus B plus B plus AI plus C minus D plus C plus DI equals 0 plus 0I. So this is A minus B plus C minus D equals 0. And this is B plus A plus C plus D equals 0. And that's going to be 1 minus 1, 1 minus 1, 1, 1, 1, 1, pipe 0, 0. This is going to be R2 replaced with R2 minus R1. That's going to be 1 minus 1, 1 minus 1, pipe 0. This is going to be 0 minus minus 1, that's 2, 0, 2, and 0. This is going to be R1 replaced with 2R1 plus R2. A equals minus C, B equals minus D, C equals P, D equals Q. And what that essentially means is A equals minus P and B equals minus Q. P replaced with 1, Q replaced with 1. What did I do? What did I just do? So what this means, ultimately, if we go back up to the top, it means that I can get A plus IB 1 plus I plus C plus ID 1 minus I equals 0, implying that minus 1 minus I 1 plus better yet, let's do it like this. Z1, Z2, Z1 1 plus I plus Z2 times 1 minus I equals 0, implying that Z1 equals minus 1 minus I and Z2 equals 1 plus I, which is not equal to 0. Therefore, dependence 1 plus I, 1 minus I. Okay? We're done. We're done with that. Yo, I gotta do physics homework today, and I might not make it till 5. I might try to go to 4:30 maybe, but I think it's not wise for me to go till 5 because I have physics homework due at 6. Packed up and ready to go. All right, let me number 1 real quick. Now I'm no longer logged in. How did I get logged out? That's the question. So it's as simple as that. All right, so yeah, V1 through V4 is linearly independent in V. Prove that this list, in terms of V1 through V4, is also linearly independent. Okay, I don't know how I got logged out since I logged in literally 5 seconds ago. End V1, V2, V3, V4. Want to show in V1 minus V2, V2 minus V3, V3 minus V4, V4. La la la. All right, so let's talk about plus B, V2 minus V3, plus C, V3 minus V4, plus D, V4, equals 0. Want to show implies A equals B equals C equals D equals 0. Well, let's break it up here. Let's talk about A1 V1 plus is this B minus A V2 plus C minus B V3 plus D minus C V4 equals 0. From the hypothesis, we have A1 equals 0, B equals A, C equals B, and D equals C, which can be turned into A equals B equals C equals D equals 0. Which is what we wanted. Boom, we're done, right? That was that. That was that. I think we can prove this. Prove or give a counterexample. If V1 through Vm is a linearly independent list of vectors in V, then 5V1 minus 4V2, comma V2, V3 through Vm is linearly independent. Now let's see. Since V2 is partially described, since V1 is, since 5v1 minus 4v2 is partially described by v2. So yeah, let's erase because this was trivial. Ba, 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 ba. That was a nice, peaceful little erasing situation that we just had. So let's say end of vk such that k is in 1 dot dot m. Such that k is in 1 dot dot m is independent. Want to show that independent of 5v1 minus 4v2 v2 comma dot 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 comma vm is also independent. All right, well, a Welsers, let's show that A1 5v1 minus 4v2 plus A2 v2 plus dot 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 plus AM vm equals 0. That's 5a1 v1 plus a2 minus 4a1 v2 plus dot 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 plus am equals 0. am vm. Based on that, we have 5a1 equals 0 because of the hypothesis. a2 minus 4a1 equals 0. Dot 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 am equals 0. Which is a1 equals 0, a2 equals 4 times a1, which is going to be 0, a3 equals 0, dot 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 am equals 0. So essentially we have a1 equals dot 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 equals am equals 0. All right, how many more of these? Because there's 17. And they get into polynomials. I'm at 8. So I'm almost halfway done. Not modulo the skipping of the thing. They might get harder. Some of these have been just trivially easy. I don't know when I'm going to stop. I think I'm going to stop in 15 minutes, y'all. I know I did only 2 hours last week, but I think I need to do only 2 hours this week again, which I feel bad about, but you know, it's gotta happen. It's gotta be that way. Because I got physics homework to do. I'm playing with this button that I found. It's a button and a twirly tie. See it? All right, let's do it. Let's do number 8. This proof was trivial, but it's good to get the reps in. fix some lambda not equal to 0 in F. In V1 through dot dot through Vm. Want to show in lambda V1 lambda Vm. So let's talk about A1 lambda V1 plus dot 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 plus AM lambda Vm equals 0. Pull the lambda out front. AM Vm equals 0. And divide both sides by lambda. Then by the hypothesis, for all k in 1 dot dot m, ak equals 0. Boom. It's easy. Bum, 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 bum. Now, number 9. If V1 through Vm and W1 through Wm are linearly independent lists of vectors, then A1 plus W1 blah 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 is also linearly independent. Okay. Okay, here we go. Want to show in V1 plus W1 dot 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 comma Vm plus Wm. Place where nobody knows. equals 0. I don't know what to do here. Because if I break this up, like this, it's a bad sigma. That's not sufficient to conclude this. That's just not right. That's not right at all. Because you could show a counterexample. So maybe I should give a counterexample. Maybe I should give a counterexample, you know? Maybe I should give a counterexample. A singleton set of vectors is linearly independent. No, VK and WK replaced with minus 1, 0, 0, dot, dot, dot. So that would be A1, 1 plus dot, 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 0 plus A1 minus 1, 0, dot, 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 0 equals 0. Vector. Then A1 replaced with 1. So 1 minus 1 equals 0. 0 equals 0, dot, 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 0 equals 0. That's a counterexample. All right, I think I'm going to call it here, unfortunately. I think I'm going to call it here because I have to do physics homework. Yeah, I think it's going to be a stop stream, everybody. So I can do physics homework, unfortunately. All right? Is everybody good with that? I'm going to stop streaming.